Okay, here we've got weak base, strong acid titration curves. Here we've got our strong base with a strong acid. You'll notice that the pH is relatively close to 14. What am I adding here? Yeah, here we are adding HCl to NaOH. And then in the one underneath it, we've got NH3, which is a weak base, with HCl, which is a strong acid. You'll notice that the pH has dropped. Okay. Here they are showing you the buffer region. And note here, your equivalence point up here with the strong base and strong acid is at 7. Here your equivalence point is less than that. It looks like the equivalence point is somewhere around 5. Let's turn to the next page. Here? Right? Okay, good guess. Okay, so what am I looking for? The cation. Okay. The cation from the salt is a weak acid, and it's going to give protons to water. That's how you produce hydronium ions. That's how you get your pH to be below 7. Okay? That's pretty much all I'm highlighting on that page. Take a look at the next page. Okay. All right, the pOH equals the pKb of a weak base at the halfway point. So exactly halfway to the equivalence point, half of the base has been converted to its conjugate acid. Okay, so here the hydronium ion concentration would equal the Ka, and the pH would equal the pKa, and the, let's see here, the pOH would be equal to the pKb, and then you've got your hydroxide equal to the Kb. That's all we're going to highlight there. Turn to the next page. We already talked about that. We're good. Turn to the next, last set of practice problems, actually. So turn all the way to here. Okay, let's do number 1. They want us to calculate the pH of a solution. We're doing a titration with a strong acid and a weak base. And they want to know if the answer would be greater than or less than the pKa of the ammonium ion. Okay, so I'm going to take my strong acid, and it's 0.1 molar. We're going to multiply that by 0.013 liters. Divide it by the volume of the solution. So 25 and 13 is 38.
Yes.
So 0.038 liters of solution. Let's take a wild guess. 0.0342. Let's see. How does that look? No.
0.03. Wait, I got 0.06.
0.03?
Yeah.
Yeah. You got the 4.2?
Yeah.
Okay. And then for my NH3, this is 0.1 times 0.025 divided by 0.038. Okay, I got 0.06.
Yeah, that's the thing.
Okay. All right, so there's our new molarities from the dilution. Then we've got HCl combining with NH3. So that means you're going to end up producing Cl negative 1 and NH4 plus 1. Create your table. So this is 0.0342, 0.0658, 0, and 0. We're going to run out of HCl. So, yeah, minus 0.0342. And then I think this is 0. I think this is 0.0316. Okay. Okay. Now, the cation hydrolyzes. Agreed? Mm-hmm. So I'm going to make a note here that this hydrolyzes. So now I need to consider that. So now I'm going to combine that down here with water. So it's going to give up a hydrogen to water. And then that's going to make ammonia and, yikes, that's the wrong symbol. And hydronium, and this is what will drop that pH. Does that make sense? Okay, so now I get to do another table, right? So this is going to be 0.0342. We can disregard the water. This is 0 and 0. And then this is minus x plus x plus x, 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 0.0342 minus x. We can disregard the minus x and just leave it as 0.0342. Okay, so this you can kind of like cross out and just use this. So this is going to be x squared divided by 0.0342. And then this is equal to the value from the table, the 5.6 times 10 to the negative 10. Solve for x. I don't trust my math.
Where did the 5.6?
That comes from the K. That's the tape. Comes from the table.
But that's the K.
That's what I got.
Yeah, that's because it's just beyond halfway. So are we saying that like hydronium?
This is the K. This is the Ka.
Oh, because it's acting.
For
okay.
NH4 plus 1. Okay. All right. So you got x is equal to 4.3 times 10 to the negative 6. Okay, and then that unit is molarity. So that is my hydronium ion concentration. Okay, so that means that if I want the pH, it's going to be the negative log of 4.3 times 10 to the negative 6. What did you guys get? Yeah, I got 5.36-ish, somewhere around there. Okay, so that it? We answered all the questions? Yeah? Okay. And I think we're done. That's it.